Problem 18, Quantum Mechanics. The question is, the motion of a particle of mass m in one dimension is described by the Hamiltonian h is equal to p square by 2m plus half m omega square x square plus lambda x. What is the difference between the quantized energies of the first two levels? We have to find out the difference between the energies of the first two levels. Here the Hamiltonian is given by p square by 2m plus half m omega square x square plus lambda x. Here we can see that the Hamiltonian contains a perturbation lambda x. That is the total Hamiltonian equal to p square by 2m plus half m omega square x square plus lambda x, where lambda x is the perturbation. We can write h is equal to h0 plus h dash, where h dash is equal to lambda x is the perturbed Hamiltonian, or it is the perturbation. So a perturbation lambda x is applied to the Hamiltonian p square by 2m plus half m omega square x square. Now the energy is changed. We have to find out the difference between the energies of the first two levels. Now when the Hamiltonian is this, what is the total energy? The total energy can be expressed as En equal to En0 plus En1 plus En2 plus etc. Then what is En0? We can say En0 is the unperturbed energy that corresponding to the Hamiltonian H0. What is H0? H0 is equal to p square by 2m plus half m omega square x square. This unperturbed energy is, we know, it is n plus half h cross omega. Now due to the perturbation lambda x, there will be correction to the total energy. Let it can be represented as En1, En2, etc. Where En1 is the first order correction in the energy En, and En2 is the second order correction in energy En. We can write En1 as the first order correction in energy. It is a first order correction in energy En0. And what is En2? It is a second order correction in energy. Now we have to find out what is the first order correction in energy and the second order correction in energy. Then together with En0, we will get the total energy. Now how to find out this En1, that is the first order correction in energy? The formula is En1 this is equal to n h dash n, where h dash is the perturbation. We can write En1 that is equal to n lambda x, because h dash is equal to lambda x, n lambda x n. H dash is equal to lambda x is the perturbation. Now you can take lambda outside because lambda is the constant, that is lambda into n x n, that is basically the expectation value of x. Now in the case of harmonic oscillator, we have the expectation value of x is 0. So the first order correction in energy is 0. Now let us find out what is the second order correction in energy. Now how do you find out the second order correction in energy in the case of harmonic oscillator? we represent it as En2. It is a second order correction in energy due to the perturbation. Now En2, the formula for the second order correction in energy is sum over m not equal to n. Then modulus of m h prime n whole square divided by En0 minus Em0. This is the formula to find out the second order correction in energy En2. En2 is equal to sum over m not equal to n modulus of m h prime n whole square divided by En0 minus Em0. To find out En2, we have to write our x in terms of operators. What is x? We can write x is equal to h cross by 2m omega whole raised to half a plus a dagger. So that our perturbation lambda x become, h dash is equal to lambda x become lambda h cross by 2m omega whole raised to half a plus a dagger. Now substitute the value of h dash in En2. Substitute the value of h dash in En2. You will get En2 is equal to, now you can take lambda square, then h cross by 2m omega outside, then sum over n not equal to m modulus m, then a plus a dagger m whole square divided by En0 minus Em0. En0 minus Em0. Now let us separate the term and write En2 is equal to lambda square h cross by 2m omega sum over n not equal to m a n plus m a dagger n whole square divided by En0 minus Em0. Now what happens when a operates on n? When a operates on n, you will get root n minus 1. Similarly, when a dagger operates on n, you will get root of n plus 1, n plus 1. Therefore, En2 is equal to lambda square h cross by 2m omega sum over m not equal to n. En2 is equal to lambda square h cross by 2m omega, then within bracket modulus you will get root n m n minus 1 plus root n plus 1 m n plus 1, then the modulus square divided by En0 minus Em0. Divided by En0 minus Em0. Now, after simplification, you will get En2 as lambda square h bar by 2m omega into n by En0 minus En minus 1 0 plus n plus 1 divided by En0 minus En plus 1 0. Now this simplifies to lambda square h cross by 2m omega within bracket n by h cross omega plus n plus 1 by minus h cross omega. This is because En0 minus En minus 1 0 is h cross omega and En0 minus En plus 1 0 is minus h cross omega. Thus we have En2 that is equal to, after simplification you will get minus lambda square by 2m omega square. Minus lambda square by 2m omega square. This is the second order correction in energy. Now we have the ground state. Now we have the energy corresponding to the unperturbed Hamiltonian En0, also the first order correction in energy En1, and also the second order correction in energy En2. Now our total energy, because of the given Hamiltonian, is given by En, that is equal to En0 plus En1 plus En2. Now what is En0? En0 is the unperturbed energy corresponding to H0. H0 is p square by 2m plus half m omega square x square. Therefore, En0 is equal to n plus half h cross omega. Now the total energy En is equal to En0 plus En1 plus En2. That is n plus half h cross omega plus, what is En1? En1 is 0. We have already determined En1 is equal to 0. And what is En2? En2 is minus lambda square by 2m omega square. This is the total energy corresponding to the given Hamiltonian p square by 2m plus half m omega square x square plus lambda x. Now in the question, the difference between the energies of the first two levels are asked. That is, we have to find out the difference between E1 and E0. We have to find out the difference between E1 and E0. To find E1, just substitute n is equal to 1 in the above equation, and for E0, substitute n is equal to 0 and take the difference. This is equal to 1 plus 1 by 2 h cross omega minus half h cross omega, that is equal to h cross omega.